Thank you. Yeah, I'm happy to be here. This is my second PyCon. I was here. I was in Atlanta in 2010, and I took a year off, and now I'm back, and I've written a lot of new code, and I've got some fun things to talk about. So I started out as a mathematician, and then I went and worked in the quant finance business for about 3 years, and then I left in the middle of 2010. And since then, I've been doing statistics, and I've been consulting and doing open source and working on libraries like pandas. Very exciting right now. I've just started a company called Lambda Foundry, Lambda like the Lambda calculus, and Lambda in Python. So we're building a research platform for quants in Python and built on top of pandas. So doing a lot of development in and around the pandas ecosystem. So I spend a lot of time like this. I care a lot about performance and building high performance tools in Python. So I spend a lot of time with my mad scientist goggles on, behind the monitors and trying to eke out performance in Python and build good APIs, and so this is my natural state. I'm writing a book, so I've got a book in the works with O'Reilly Media. It's called Python for Data Analysis. So I looked around about a year ago, and I saw that there really wasn't a book that presented a really nice introduction to what I would call the modern scientific Python stack. So I decided, well, for the good of the community, this book needs to be written, and also Pandas has reached a mature state where I'm comfortable writing about it in a book. So the goal is to present a very practical guide for new people coming to Python, but also existing Python programmers who want to work with data and be able to apply these tools in their work. And it's going to be coming out later this year. So pandas, so we've got a new website. It's at the new pydata.org, which you'll be hearing more about in the coming months. It is a rich data manipulation tool which sits right on top of NumPy. So so if you have that question, it's based on NumPy, and you can think of it, if you're an R user, as like a data frame on steroids. I wasn't the first person to call it that, but I've taken to it, and I think it's a good description. I've invested a lot in building very high performance tools for working with tabular data in Python. A lot of the work is in building very consistent and easy to use APIs, so that when you're flipping between different parts of the library, that you don't have a lot of cognitive dissonance and things really mesh well together, so that you can really get things done very fast. And I'm hoping that Pandas will be the foundation for building a next generation data analysis environment, and doing it in Python, because I think we all want to be programming in Python. So that's why we're all here, right? So it's being used by a lot of, I started out in the finance industry, and initially Pandas was very well suited for financial data, because that's what I was building it for, and I've since expanded it to work with a lot of different kinds of data and a very broad set of problems. But there are a lot of financial users, and a lot of other people are using it very heavily in production. Performance is great. Like I was saying, I really would like to see more people using it and sort of uniting with and building a data analysis ecosystem based on pandas. So and really it's about building better tools to simplify the data wrangling process. There's been a lot of work in recent years to build better statistical modeling tools, better things like working on the data infrastructure, Hadoop and HDFS and all these tooling around data. But there's been less work on the data preparation, data cleaning, data munging process, and that's really where we spend a lot of our time. And the reality is, out in the industry and all over the world, people already are using Python to do this work, to do data wrangling, data preparation. But there really has been a gap in the analysis tools, where you do a lot of work in Python, and then you have to sort of stop. You dump out the data that you've been preparing in Python, and you load it up in R or another environment. And that's the thing that I'm trying to change. So. You can see there's a bit of an inflection point in the code churn graph, where I decided to devote myself full-time to the project beginning of last summer. It's grown and by leaps and bounds during that time. There's about 10 active committers on the project. I still do a lot of development myself, but it's been really exciting to get a lot more people involved with the project. A lot of the work, of course, is in testing, and you've got to take testing very seriously. About a year ago, there were only about 500 test functions in the 0.3 release, and since then, that number has grown to about 1,500. So, in addition to adding lots of new functionality, you also have to make sure that it's code that you can believe in, that you can rely on, and build really critical production systems based on. So before I dive in and show some demos, I just wanted to briefly talk about my tools. I think more people should talk about their tools, what they use to do their development. So I'm a big fan of IPython. I talk about it all the time. I am an Emacs user, so don't hate. I know that most Python people are Vimmers or they use other tools, but I think the indispensable tool is the Python debugger. If you use it within IPython, you get a much richer experience. You get tab completion. You can debug things much faster. Use tools like pylint and pyflakes, to root out the common errors as they occur. And of course, use Ned Batchelder's coverage.py to really measure code coverage and to make sure you're covering all your bases. Of course, code coverage, line coverage can be deceiving, so that's also something to be mindful of. So. IPython project, many of you have heard of this. There's been a lot of buzz around the project. I think it's one of the most exciting projects, especially in the scientific Python ecosystem. It's something that, when I started out in Python and I discovered IPython, it really transformed the way that I do development and that I do interactive research and data analysis. Fernando and crew have really kind of engineered it to be this productivity enhancing tool that as soon as you start using it, you wonder how you ever lived without it. And I always, when I talk to general Python programmers, non-scientific Python programmers, I always recommend that you explore using IPython, even if you don't do science, if you don't make plots and do a lot of numerical computing. Because I really do think it can enhance any Python developer's workflow. And of course, if you haven't seen the HTML notebook, it's amazing, and I'll see a little bit of it in this demo. A little bit about profiling and optimization. There's lots of, I'm going to skip this, but there's lots of great stuff you can do within IPython to time code, to profile it through cprofile, to really speed up the iterative process of developing code, testing it, and making sure that it's performant. Especially in large-scale data analysis applications, you spend a lot of time tweaking things and making sure that things run fast. And so having these tools, just right at your fingertips and not have to write a lot of code to profile your code is very powerful. So there's other things, follow consistent conventions. People always complain about the 80 character limit in PEP8, but I think it's good to stick to. And avoid long functions is something I've also thought about. So I made this histogram of the pandas code base of about 2,000 functions, and I was happy to see that fewer than 20 of them have more than 50 lines. So I'm pretty good about following my own advice, and I certainly would recommend it to you. If you have a really long function, refactor it into a smaller function. It will make your life easier in the long run. So how many of you know Uncle Bob, Uncle Bob Martin? So he's a big advocate of test-driven development. I'm not much of a TDD adherent, but there's a lot of good lessons to learn from things that he's written. And I recommend that you check out his YouTube talk, What Killed Smalltalk Could Kill Ruby Too. And the basic advice is, when you have a dynamic language, often it can just be too easy to make a mess. And that's true of Python as well. So the basics of pandas, so you have a number of different data structures, and the first is the series, which is built as a subclass of the NumPy array. It's a one-dimensional object. You have an array of data, and you have an array of labels. The labels can be any type. They don't need to be any particular order. They just give an identification for your data. And that's integrated throughout that labeling is used throughout the library to reference the data, to do join operations, and really anything that you might want to do with the data. Now the data frame is taking one step back from there. You have a collection of series. You can imagine it's like a table where each table now, here we had a one-dimensional object with an array of labels, and a data frame is a table with multiple columns where each column can be a different type. And they all have the same row labeling. And so you can insert and delete columns, and you can treat it like a NumPy array. It's this very flexible object, and it's the primary container for working with data in pandas. So if you were in the PyPython shell and you this is a tipping data set, you might have something that looked like this, where you have a number of numerical columns and then a number of string columns or Boolean columns, or you could even have arbitrary Python objects in the columns. And it's sort of the entry point, and it's the container for data that you use to do your analysis. Now the indexes on the axis here, we've got integers on the rows and strings on the columns. You can have more complicated indexes. You can have hierarchical indexes. Here's an example of a data frame that has 2 levels of indexing on the rows. It has sex and smoker, as its row labels. And you can think of the labeling as being like a tuple, like the tuple female comma no and female comma yes as being the first two row labels. But you can select out subsets of the data very naturally. If you wanted to just get the slice of data that's labeled female, you can do that, and that just gives you a view on the data rather than having to copy it. And if you have a very large data set, then you can do log time lookups of slices of the data. It's much, to me, it be higher performance and much more natural than writing a lot of for loops to select out data from a list of tuples or something like that. So the axis indexing is one of the things that really sets pandas apart from really anything else that I've seen in R or any of the other, the commercial data analysis environments. And what it allows you to do, and I've started to call it enables you to do alignment-free programming. So any time, if you've ever worked with time series data or any form of labeled or relational data, how much time have you spent, munging things into a table where things are laid out a little bit differently, and you have to explicitly align things by hand, so you know that all the dates in the time series are lined up, or all of the keys match between a set of tuples. So the axis indexes are built in, and they allow you to basically not think about this problem. You have API functions to do explicit data alignment, but often it does the munging for you and allows you to sort of really focus on your analysis. So, a very simple example here, we have two series objects that are labeled a little bit differently, one that's labeled B through E and another that's A through D, but you can actually add them together, and you're not just doing an array operation, you're really doing a join where it looks at the indexes and says, no, these aren't the same, so I need to union them together, realign the two series, and then add the values together, and you see because there was a mismatch that you get missing value markers, NAs, in the result. So another very powerful concept in pandas is this idea of group by. So I'm sure many of you have written a group by statement when doing SQL or a different kind of a database framework. So you have labelings for your data, and it enables you to split the data into groups and apply arbitrary Python functions to it. Those could be group-wise modeling functions or simple aggregations, sum or median or standard deviation, and to aggregate and basically produce summary statistics on very large data sets very concisely. I'm going to show you some examples of that. So the hierarchical indexing that I talked about, basically, it gives you a way to treat a data set like having a tree of relations along one axis, so that you can very easily select out groups of data, and it integrates very naturally in the group by operations. So here in this index case, we have two groups of data. The first is the A group, which has as its inner level the labels 1, 2, 3, and then the B group has the labels 1, 2, 3, 4. So you can have uneven group sizes within each level of the tree of data. So I'm just going to show a quick demo with a couple of data sets, one of which will be familiar to anyone who is at my tutorial here at PyCon. And this is all running within the IPython HTML notebook, which if you haven't seen, you really have to. It's just this amazing project. So I've got a data set which contains about 500,000 rows. It's the Federal Election Commission disclosure data. So it's records for all of the contributors to the 2012 United States presidential election. So we have make this a little bigger here. So we have contributor names, candidate names, their employer and occupation, the amount that they donated, the date that they donated it on, and then some other metadata and things that I haven't really explored, so I can't tell you what they are. So I do a couple little munging things at the beginning. So add a party column, and I group together a couple of occupations which are spelled very differently. And the first thing that I want to do is I want to aggregate the donations by occupation and separate them by party. So the data frame object has a pivot table function, which I pass the column that I want to aggregate, the group that I want to split up along the rows of the resulting pivot table. So if you've ever created a pivot table in Excel, this is very similar to that. And then I specify the party as the group that I want along the columns, and then I can specify an aggregation function, and there's some other options And after I do that, I'm just going to filter out occupations that donated. Let's see here, clear all output. So just filter out occupations that donated at least $2 million to any candidate. And so this produces a table in this object that you get back as a data frame, and you can see that the columns are labeled by Democrat and Republican, and so the name of the columns is here, which says party, and then the row labels are the occupations that met the criterion in this statement. And so you can see that, you know, attorneys and I think retired people are the ones who donate the most money to political candidates in general. But this is a little bit hard to visualize, so you can take this object that you got back, this data frame, and do plot, use its plot method with kind equals bar, and that gives us a nice bar plot with the occupations along the x-axis, and here you can see exactly what's going on. Well, there's a big group of Republican donors who didn't specify what their occupation was. I guess they were embarrassed about it, and it turns out a lot of homemakers donate to the Republican Party, and more attorneys donate to the Democrats. Go figure, but it's really the retired folks that are opening up their pocketbooks for the election. So I also discovered while I was looking at this data set that there was this fellow down in Atlanta named James Kobe who identified himself as a zombie slayer. And I bet you can guess he donated to Ron Paul. So in the amount of $1,556. So that's pretty, he even has an LLC, Atlanta Zombie Services LLC. How about that? And so what we're looking at right now is so I've got a configurable option where I can tell DataFrame to emit HTML, which the IPython notebook then renders into this nice HTML table, which I can scroll around and I can look at a very big data set. And so you can see how, you know, with the web technologies and the IPython notebook and these editable code cells, you can really start to build, and inline plots, you can really start to build this compelling, productive data analysis environment. I'm just so excited about the tools that have gotten built, you know, in the last year. You know, this stuff just didn't exist a year ago, and so it's been really, really exciting. So another, you can do other things. So here's an example of, I wrote a little function which selects out the top three, which I'm not going to go through, which selects the top three types of occupations by presidential candidate. And so you can see for most it's retired. I guess Tim Pawlenty, you know, has got most of his donations from homemakers. And so you can extract summary statistics from the data in a very, very concise way. Tom, how am I doing on time? Okay, so I've got 12 minutes left. All right, I'm going to skip the second data set. Well, I thought I had 40 minutes, so that's my mistake. So as a last example of something we could do, so this is something a little bit more complicated. So I wrote a binning function for, let's see, let me turn back on the HTML feature so you guys can see it. So here is a histogram of a number of the major candidates and binned by contribution value. So you write a binning function, you bin the amounts, and you pass that to group by, and you can get a histogram of how many donations within each group. And so you can see that, you know, for example, let's see. You know, Ron Paul has got a lot of really small donations, whereas, you know, Mitt Romney's got a lot of, you know, donations between, you know, 1,000 and 10,000. So you can get an idea of what's going on in this data set. So back to the slides. So very briefly, you know, a lot of people ask me, what's in pandas? What's it going to do? I made this bar plot of, you know, these are the sub packages of pandas, and so the biggest sub-package is the tests, and so many of these have just come out of working with real-world applications for the last 4 years, and honestly, I mean, that's probably the most valuable thing in the library. There's 68 lines of tests for every 100 lines of production code. You know, a lot of people, you know, using pandas. There's also other fun things, especially with the web notebook, we can start to think about building interactive visualization tools written in JavaScript like D3 and Flood and all the JavaScript plotting libraries, and have that integrate in the IPython HTML notebook. And I think the trick would be building rich interactive visualizations that are where the code is written in Python and you generate these nice visualizations, and it all runs within the IPython notebook. There's also a lot of interest in building other backends for data frame so that it can work with big data, so memory mapped files, and figuring out how pandas could connect to a Hadoop-based environment, so you can write all of your maps and reduces as pandas code. Like I was saying, building tighter integration with the IPython notebook. There's a lot of interest right now in building, generally speaking, building better statistical graphics functionality in Python. If any of you use R, the ggplot2 library is fantastic for building really attractive, rich, static visualizations in R. And we really need something like that in Python. And it would be great to use pandas as the base layer for that. And if we could also do it in an interactive way, that would be even better. So if any of you know Peter Wang, I think he's going to give a lightning talk on this, so talk with him. There's a lot of interest here, and I think we've got the momentum to make this happen. So the pandas for big data questions, so having rich data tools that can operate on big data. Right now, pandas is an in-memory data tool, and I haven't, having not had to work with big data, I just haven't had to invest time in the big data problem. So there's a lot of opportunity here, and so if you have big data, you want to use pandas. This is another entry point. So I care a lot about performance, so much so, and the question is, we all test our code, but how many of us actually test the performance of our code on a systematic basis? And I was doing this all the time, and I'd work on something, I'd get it really fast, and I'd come back a few months later and found that it got slower, and I'd track down the commit where that happened, and I'd sort of, be a lot of, face palms, not realizing that something I did had unintended consequences. So I needed to scratch my itch, so I started this little project called vBench. So if you're interested in monitoring the performance of your code in a systematic way, it's a very lightweight framework that integrates with Git. So you can point it at your code base, write a little bit of setup code, and then write some small little benchmark objects, and it will create a graph of the performance of a statement over time. And this could be something that takes less than a microsecond, and you can still get meaningful timings. So if you have a function that takes 1.5 microseconds, but you call it 100 million times in your code, any small changes in that function could really impact the runtime of your process. So I'm excited about this project, and if you care about performance monitoring, so this is actually a graph from one of the pandas vBench suite, from the pandas vBench suite. Here's something where I see in early February, I made it a lot faster in the middle of December, and then in early February, it looks like there was a performance regression. So I looked at this and I said, I've got to go look into this and see what happened, because this is something that I want to be really fast. So, well, if your head's spinning yet, I guess I've got a couple of minutes, but I think maybe I can just take a lot of questions. You can follow me on Twitter. I talk a lot about data and other nerdy topics. WesM on GitHub. I have a blog. It's at blog.wesmckinney.com, where I write about things not nearly as often as I should. My company, Lambda Foundry, is on Startup Row tomorrow, so definitely stop by the booth and talk to us. And generally, I think the future is bright for working with data in Python. There's a lot of exciting stuff ahead, and I'm really excited to have as many members of the Python community, especially you guys here, involved with the effort. So I think really, there's so much momentum building right now, and I see a lot of great things happening over the next year or two. So thank you guys.
He did finish a little early, so we've got a little bit more than 5 minutes available for questions. I'd like to start, and we've got microphones set up here and there. Could you talk a little bit about the statistics that you already got working with pandas? Because I know you've got a fair amount with that.
Statistics in general?
Yeah.
Okay, so the question is what statistical tools do I have working with pandas? So inside pandas, there's a fairly nice implementation of linear regression models and moving window linear regression models. And I built that, with the financial user in mind, and that works very well. There's some preliminary integration of pandas with stats models. It used to be scikits.stats models, but we just got rid of the namespace. And so you can pass data frames to a model in stats models, like a generalized linear model. And when you get the parameters back, it will be a pandas series with the parameter names attached to it. So it's getting richer. We want to add a formula framework, so like a nice way to specify linear models, similar to R, and that's an ongoing project and a lot of work to do there. But I think it's very definitely something where people can get involved very easily.
Can you modify like the data set in real time so we can have like some data streaming in and have the data set and the associated like pivot table change?
So the question is if it's possible to have streaming data in pandas. I don't see any reason that you couldn't have so the data source and so the data frame front, like the front end, like what you actually are interfacing with, and where the data comes from are separated. So there's no reason that couldn't be a streaming data source. So it's largely just a function of my not having had to work with that. And you could imagine building like a circular buffer or something like that. Or you could have under the hood you could dynamically resize the NumPy arrays that contain the data. So that, I think a number of people have asked me about that, and I think it's doable. Yeah, but there's nothing there for that yet.
Yeah, so there is always this huge challenge to try to match the diversity of, say, predictive modeling methods in R.
So I'm sorry,
There is this huge diversity of, say, predictive modeling methods in R, like
Yes.
hundreds of various things available. How are you going to, what are your plans of getting to that scale?
I guess the question is that there are hundreds of packages and methods and tools that people are already reusing in R. Well, I guess you have to start somewhere. I don't think I don't think it makes sense to go and start to port all 3,000-4,000 R packages, but I think there's a standard set of 20 or 30 packages that are extremely commonly used that could address 80 or 90% of people's use cases, and that would really go a long way toward enabling many people to do all their work in Python. A lot of the underlying statistical functionality, probability distributions and basic things you need to do statistics are already there. It's mainly just a matter of polish and user interface at this point.
So most of the kinds of data analysis that I want to do usually involves munging logs from an application server. And so instead of having time series where there's a fixed set of instance where I have a value, I instead have a lot of events that happened at various times. And then I want to aggregate, but also want to split it apart. I know that I get certain method calls that take so long, other method calls that take a different amount of time. When the application server CPU spikes, I'd like to know what kind of method is causing that change when we do a release. And I haven't seen that kind of tool built into things. When I see time series analysis, I'm like, I think I have a time series, but I don't.
Right.
I have a bunch of events that I have to convert into a time series, and that's usually the pain point for me.
Yeah, no, I think this would definitely be an ideal tool for that. Out of the box, it works. You can throw irregular time series into it, which it sounds like what you have.
Well,
and that you might.
Yeah, it's not quite an irregular time series. It's a series of events.
Right.
And each event took a certain amount of time, and I don't care about the time each individual event took. I care about the aggregates over slices of those events.
Well, I guess what you would have is you would have events with timestamps.
Yeah.
I guess, right? And so you would create an object with the rows being those the data associated with those events along with the timestamps, and then you would define the intervals of time, or however you want to actually aggregate that. You could define the way that you want to aggregate it, and then then sum all that up to create the sort of the regular series, or to get this was the amount of to get those spikes and to actually analyze that. And I think you could do that. I think you could do that very easily with this tool. Yeah.
Can you describe in a little more detail the time series utilities you have for generating time series? And specifically, can you take user counters, user-provided counters that define what's the meaning of a holiday, what's the meaning of a business day, et cetera?
Yeah, so there's a date range function which generates which can generate a range of dates given a rule, and so the idea is that the rules are extensible. So you could implement a custom rule which has it has an interface, and you implement the method. Implement sort of your proprietary your specific logic for generating saying here's a date and I need to move forward one period, but that might skip over a holiday or something like that. And so you could do that and then pass that to the date range, and it would generate the dates according to your domain logic.
Okay.
Okay, thank you very much. Thank you, Wes. Great job.